So far, we have limited our discussion of quantitative data to graphs and pictures. Now we turn our attention to numerically describing our data. For categorical data, that was easily. You calculated the proportion of cases that fell in a certain category. For quantitative data, it is quite different. The two outstanding features we will focus on are where is the data centered and how spread out is the data. We begin with the question, where is the data centered? So here is our now familiar data set with 23 student pulse rates arranged from largest to smallest. In an earlier lesson, we constructed a stem and leaf display for this data. And now I have identified on the graph the middlemost data value. It is the 72 that is highlighted in red. If you count, you will find that there are 11 data values that are less than 72 and 11 data values that are greater than 72. We then call 72 the median because it cuts the data into two equal parts, area-wise. The median is a number such that 50% of the data is below the median and 50% of the data is above the median. So in the next few slides, we will focus on how to calculate the median of a data set by hand. If your data set is large, you will use commercial software to find the median. I'm going to give you a handy little rule. First, I want you to start by sorting your data. We are in the habit of sorting it from largest to smallest. Then I want you to count the number of data values. We'll call that number n. Then I want you to add 1 to the number of data values, and then follow that up by dividing by 2. This will give you the position of the median. So here is the procedure applied to the pulse rate data. The data has already been arranged from largest to smallest. There are 23 observations. So we compute 23 plus 1, which is 24, divided by 2 is 12. This tells us that the median is in the 12th position. So we go into our data set and count 2, 4, 6, 8, 10, 11, 12. The median is 72. The median is 72 beats per minute. Let's consider adding an extra observation to the data. On the low end, I have added a student with a pulse rate of 50. Now there are 24 observations. And when we do our calculation, n plus 1 divided by 2, we're going to get 25 divided by 2, or 12.5. What this is telling us is that the median is between the 12th position and the 13th position. So what we have to do is we have to average the 12th and 13th observation. This is not very interesting in this case since they have the same value, namely 72. So the average will be 72, and the median is again 72 beats per minute. In general, however, the middle two observations may in fact be different. We end with an example to illustrate the impact of an outlier on the median. Notice how I changed the former largest value of 91 to 110. Most would consider 110 a high outlier since it is much larger than the other pulse rates. You will notice, since there are still 23 observations, the median will still be in the 12th position, so the median remains 72 beats per minute. Outliers are not impacted, do not impact the median. This is really important. When your data set is skewed, because there are outliers, the median is the best measure of center because it is resistant to outliers.